All right. I thought I would go ahead and do a video on subnetting. There's tons of these videos on the internet, and I had a hard time finding very many that were useful to me. Subnetting is something that I see a lot of my students struggle with. It's not unusual to struggle with subnetting. It's a tough concept to wrap your head around because as humans, we're used to counting using a base 10 numerical system. Once you start throwing in conversion between base 10 and binary, it confuses things a little bit. But as humans, we understand things one way, and computers understand things another way. So we have to learn to translate between what we know and what computers expect. Commonly, what you'll see on certification tests, whether you're testing for the CCNA exam through Cisco or you're taking the CompTIA Net Plus exam, it's very likely that you will see subnetting questions. A lot of people struggle with this. Again, it's not unusual to struggle with this. So if this is a concept that you're having a hard time mastering, don't worry. Many of us have been there. What I want to show you is a system that works for me to help me calculate subnet boundaries and to quickly and easily determine some of the information that a question may ask for. Some questions will ask you to determine the network address, first host, last host, and broadcast address. Other questions may ask for simply one of those items. So if you look here, I've got a few steps outlined, and I'll go over these as I work through this problem. To line this out, my step one is to find the block size using something called the magic number concept or shortcut. Plenty of videos on YouTube that will explain it. I will demonstrate it here with this table that I have typed out here that represents the 8 bits inside of my octet where we'll be subnetting. Once I find the magic number that determines my block size, I can easily find out what my subnet boundaries are. Once I've determined my subnet boundaries, at step 3, all of the other things quickly and easily fall into place. At the top here, I've got an example IP address typed out, and the subnet mask is represented as CIDR notation, classless interdomain routing. You may see these questions represented like this. Additionally, they may have these represented with the subnet mask written out. The subnet mask, just like the IPv4 address, is a 32-bit value divided into 4 octets and represented as dotted decimal notation. So this is a /28 subnet mask, and I know that each of my octets are 8 bits, so 28 divided by 8 is 3 with 4 left over. So my first 3 octets, all my bits are on, and it's represented by 255 in dotted decimal notation. So I'm subnetting in the last octet. How do we find out what that value is? Well, as I said, we're borrowing 4 subnet bits in that octet. Okay, so to find this value, and this is just a very basic crash course on binary to decimal conversion, we look at our bit values that are on, as represented by the number 1, and we add those values together. 128 plus 64 is 192, plus 32 is 224, plus 16 is 240. So my subnet mask is 240. Also, with that written out, I can determine my magic number. If you look at your last bit value that is on, right above it is the number 16. That tells me that my networks or my subnets increment by 16. Starting at 0, I will have the 201.200.105.0 network. Then I will have the 201.200.105.16 network. Then the 201.200.105.32 network, etc. So, we have found our block size and our magic number. From that, we were able to determine what our subnet boundaries are. Now we need to determine our network address, our first host, last host, and broadcast address. So we want to look for the subnet that is less than the IP address. It cannot be greater than the IP address because that would be the next subnet. So looking at our IP address, it's 201.200.105.87. So let's count by 16. We've got 0, 16, 32, 48, 64, 80, 96, and I'll go ahead and stop there. 87 is greater than 80 and less than 96. So our network address, based on this subnet mask, is going to be 201.200.105.80. What's our broadcast address? Well, as I said, our next network is 96. So our broadcast for this network will be 201.200.105.95. And then it's very easy to find our first and last hosts. We just increment our network address by 1 to find our first host. And we subtract 1 from our broadcast to find our last host. Easy peasy. Now what about if the subnet mask were to change? What if we are using less bits to represent the network portion of our IP address? Well, this still applies no matter which octet you're subnetting in. And really quick before I move on, I will show you a quick way to determine at least some of the information pertaining to the network address. If you see an IP address and a subnet mask represented here, wherever you see 255, you can drop down the numbers above it. As you can see here, these first 3 octets are dedicated to representing our network. So here you can see that these match. Our next network again, 201.200.105.96. Our previous network, 201.200.105.64. Those values don't change. The one that increments is the one where our value is not 255. If this value were 0, this would be represented by a /24 mask. To find your network address, it's quite simple. Again, where you see 255, you drop down those values. (201), 200, 105. But then what about here where you see 0? Well, quite simply, drop down a 0. And that determines your network address. This is only true when you're subnetting on octet boundaries. Okay? Let's change this to /9. This completely changes all of our information. So I will go ahead and delete this. And this changes our subnet mask. So again, each of these octets represents 8 bits. CIDR notation tells us how many bits are used to represent our network. We have 9 bits, so our first octet, all bits are on, that's 255. And we are 1 bit inside of the next octet. So if we go down here again to this table that I have written down, being 1 bit in the next octet, no other bits are turned on, not only is our magic number 128, but our subnet mask is also 128. And then the remaining octets will be zeros, okay? So I'll do that shortcut and show you how this applies. For my first octet, I can drop down 201. I don't know what to do with my second octet yet, but I know that my third and fourth will be 0. So now I need to find out how my networks increment in the second octet. Again, our block size is 128. So one IP address will be, or one network rather, will be 201.0.0.0. The next network will be 201.128.0.0. As I look at my IP address here, I see that 200 is greater than 128. So my network address is 201.128.0.0. I will go ahead and copy and paste that here. Maybe. There we go. So then what's my broadcast address? Well, that's not really hard to figure out either. Remember that each of these octets can be a minimum of 0 or a maximum of 255. My broadcast for this network is going to be 201.255.255.255. I subtract 1 from my broadcast. That tells me my last host. I add 1 to my network. That tells me my first host. The point here is that this trick applies no matter which subnet, or which octet, rather, that you are subnetting in. From this information here, again, with these 3 steps, this allows me to quickly determine my network address and subnet boundaries. Once you find your subnet boundaries, everything else falls into place. This will make the difference between taking upwards of 20 minutes, possibly, to answer a question pertaining to subnetting, and ideally allow you to do this in just a couple of minutes. Once you get good at this, generally it will take you about a minute to figure out your information based on the 3 steps that I've listed here. Again, the 3 steps I use are to find the block size using the magic number, and then calculate my subnet boundaries. Again, this is really using multiplication. If you want to, you can add everything together. Just keep in mind on these certification exams, they don't allow you to keep a calculator. So if you struggle with multiplication tables, something that you want to practice with, okay? And then lastly, once I've figured out what my subnet boundaries are, it's easy for me to determine what my network address is, my first host, last host, and broadcast addresses. Everything else just falls into place. Lastly, if you see any questions that ask you how many host IP addresses are assignable from a certain subnet based on either the subnet mask or CIDR notation, these are the formulas to determine. This one here pertains to the number of usable IP addresses. So using this up here as an example with /9, this is a 32-bit value. So if I subtract 9 from 32, that would give me 23. And so therefore I would have 2 to the 23 minus 2 usable host IP addresses. The number of networks resulting from this are 2 to the 9. So these formulas will help you also on the exam to quickly answer those questions that pertain to either the number of networks based on the CIDR notation or subnet mask, or the number of usable host IP addresses. Again, you subtract 2 from host addresses because your network address and broadcast addresses are reserved and not assignable to other hosts on the network. I wish you all the best of luck. Again, I know that this concept can be hard to wrap your head around, but I would argue quite simply that if I can do it, so can you. It just takes practice. There is a website. I will put a link to it in the comments of the video, or actually in the description, that I use in class for my students to practice with. Practice, practice, practice exposure is what's really going to help you master subnetting concepts.